Hello there, my name is Anthony Meli. Welcome to my one idea video using computer algebra systems to support learning mathematics. There is an accompanying document which should be made available to you along with this video. You can download or print it. Here's what we're going to be talking about. I'm going to begin by having a short discussion about algorithms. And then we're going to be talking about computer algebra systems, what they are, what they look like, and hopefully ending with some discussion questions. Here's an example of something we might ask students to do in some of our high school math courses. In this case, it's completing the square. And you see there's a number of steps. Students have to remember what to do in each of the steps. And there certainly are things that can go wrong along the way. If I was just to change the coefficient of the x term from an 8x to a 7x, you'd see it would get rather complicated very quickly, and students would be sort of stuck dealing with fractions. A lot of our students who might be able to do a simpler version would certainly fall down by the time they got to this version. And it doesn't even address the issue of, which I think is more important, why are we completing the square? I have had students who were able to do this operation and get the vertex form, but didn't know why they would need to do that, or when they did it, what it was that this told them. Of course, you know, we would like them to know that the vertex form tells them something about what the graph looks like, what the quadratic would look like, what the vertex is, how it opens, how steep it is, or whether or not there's a stretch factor. And you know, if this was modeling some sort of a function which was quadratic, then it would tell us something about what the maximum or the minimum value of that thing is. And I think that those are really far more interesting questions than just being able to generate the vertex form by completing the square. This is an example of an algorithm. So an algorithm is a process or a set of rules to be followed in calculations or other problem-solving operations, especially by a computer. Computer algebra systems in general are any mathematical software with the ability to manipulate mathematical expressions in a way similar to the traditional manual computations of mathematicians and scientists. So if a regular calculator can perform arithmetic operations on numbers, then a computer algebra system can perform algebraic functions or operations on variables as well as numbers and even functions. So basically, if we can teach kids how to do algebra, then a computer algebra system can generally do that kind of algebra. If you have access to Texas Instruments TI Inspire CAS handhelds, they have computer algebra systems built in. There are handhelds like graphing calculators, as well as software or even an app for the iPad. If you have any device that has access to the internet and has a browser, then you can point to geogebra.org, and there's certainly some well-used graphing software there. But more recently, GeoGebra has made a computer algebra system available. When you type in the URL, you want to put geogebra.org/CAS, and then you have access to the computer algebra engine. You may be familiar, like me, in my undergrad years, many years ago, I used Mathematica and Maple and programmed in it. More recently, the people who made Mathematica provided Wolfram Alpha available for free online. Very powerful computer algebra systems, as well as 3D graphing software, etc. I want to give you a chance to see what it looks like. So if you happen to have access to a TI Inspire graphing calculator, you can follow along with me. Or if not, you can follow along with me on geogebra.org/CAS. So what I'm going to do is just minimize this and open my graphing calculator software, and I'm going to start a brand new page, just a calculator page, and we're just going to start riffing here. Like 2x plus 3x is 5x. You see it added those terms because they are what we call like terms, and it knew that. What I'm going to do is add that in here again, and this time subtract 4x squared, and maybe add 7x squared. And calculator knows that 2x and 3x can be added to give 5x, but it also knows that negative 4x squared plus 7x squared adds to 3x squared. So it adds the like terms and doesn't add the unlike terms. What else can we do? We could, instead of adding x's or x squareds, we could try adding, I don't know, deer. So we could say deer plus 3 deer is 4 deer. And that works fine for deer, or it works for moose pretty well too. But if you do 1 apple plus 7 apples, it will complain and say, well, it doesn't complain actually, it just doesn't add them. So first of all, it dropped the 1. 1 apple is the same as apple, but 7 apples, plural with an S, spelled differently than apple without an S. And because of that, doesn't add them together because it doesn't think they're like terms. It doesn't do that with deer because the plural form of deer is still deer. It would be like if I added 1x to 7xs. It treats those as not like variables because the variable, sorry, not like terms because the variable coefficient is slightly different. So just like that. Let's see now, we can do other operations besides simplifying polynomials. We could ask the Inspire CAS to factor something. So x squared minus 25 is a difference of squares. It has 2 binomial factors, x minus 5 and x plus 5. Or we could, let's do 6x squared minus x plus 15. That doesn't have nice factors, but if I do plus x and minus 15, then I get some binomial factors. 2x plus 3 is one factor, and 3x plus 5 is the other. Or I could go the other way. I could ask the CAS to expand, and when I ask it to expand, I could give it 2x minus 3 times 3x plus 5. And I think I need another bracket in here. That's better. And look at that, it goes back to the trinomial form that we started with before we factored it. Or, we could ask it to expand something where it just has to distribute, like 3x times 2x minus 7. And it says, oh, invalid implied multiply. And I get that every now and again. So in this case, it wants to know that 3x has to get multiplied by this bracket. I need to be real specific about it. And then it goes ahead and distributes it and multiplies the 3x times the 2x and the 3x times the negative 7. Pretty cool. It can solve equations. I could say 3x minus 1 is equal to 14. Now, if I just hit enter now, it's going to complain. And it says too few arguments. And it's because it wants me to tell it what variable to solve for, even though it seems obvious to you or I. So I'll put a comma x, and then it'll solve it as x equals 5. That's the value of x that makes that equation true. We can solve systems of equations or multivariable equations. We can ask it to isolate one variable or another. So pretty cool. Earlier, I was showing you what it looks like to complete the square. Complete square is a function we can use here. I could say 2x squared plus 8x, and we can do that. But again, it wants to know, what do you want to complete the square around? And I'm going to say complete the square around the variable x, please. Or if I want, instead of making it nice and pretty like 8x, I'm going to make it a 7x, and then it's going to be ugly, but it can still do it. It doesn't even blink. All right, now that's what the Inspire CAS looks like. If you have the handhelds, they look a little bit more like this, but I usually use the side screen because it's a little bit bigger. On the other hand, we may want to use GeoGebra. So let me just go to a browser here and geogebra.org/CAS will get us the computer algebra system. And, perfectly free. All you need is a browser. Or if you want, you can download it on your smartphone for Android or Apple. Same thing, really. I can just type in any expression that could be simplified, and it'll add the like terms and won't add the unlike terms. This has an extra little bonus. It adds in a graph. So you see this particular expression is a quadratic expression. It has a solution at x equals 0 and a solution at probably 6/5 or something. Maybe you don't want the visual representation, so we can sort of close that off or just focus on the algebra. I don't know, we could ask it to solve 5x plus 1 equals 16, and does x equals 3. You notice I didn't have to tell it what variable to solve for, so the syntax is a little bit different than on the Inspire. Or I could, rather than ask it to expand, like I did on the Inspire, there's an example there. With the GeoGebra, I actually don't have to do that. I could just say 3x times 2x minus 1, and it'll automatically expand it because it's going for a simplified form. And when this is given in factored form, it goes, no, we can do some of those operations. So it just goes ahead and does them. So the syntax is slightly different using GeoGebra versus the Inspire, but it does basically the same things. Now, there's one other bit of software that I want to show you. It's also available online. It's called Graspable Math, and it's really cool. I've just discovered this this spring, and I think they're still working on it, to be honest. It's not quite a computer algebra system, but it has a lot in common. What you do is you just gesture, and so all you need is a touch screen. You don't necessarily have to type anything, or you can do very little typing and just mostly directing. So here, for example, 2x plus 3x minus 4x squared. I didn't give it a command. I'm just going to type that in. If I click on the plus sign, it's going to add 2x plus 3x because they're like terms, and we get 5x minus 4x squared. If I were to click on this minus sign, it's going to shake me off and say, no, you can't do that, Anthony, because these aren't like terms. So I could show my steps. There's not much going on there. That's now simplified. But here I've got an equation. It's got two terms with x in it. I'm going to want to move the 3x term to the to the right side. I'm going to grab it and just drag it over. And it says, okay, minus 3x on the right side instead of adding 3x on the left. And I want to take this 3 and I want to drag it over to the left side. Now my like terms are together, my constants are here, and my variable terms are there. And now I've got my solution. X is 7. But I had to tell the computer what to do. I gestured and it did what I asked when I asked it. You might not like that the x is on the right side, so I'm going to click the equals and it's going to reverse it, and there's all your steps. It shows what you did. It gives you your answer. I want to do 1 deer plus 3 deer? No problem. It's 4 deer. And I want to show my steps. There's not much to show there. Here's one where I might want to distribute or expand this. Now, if I just click on the multiply, that's funny. Double tap, okay. It distributed the x, but it didn't take the 3 with it, so I don't like that very much. Instead, what I'm going to do is I'm going to grab the 3 and the x, and I'm going to drag them across, and then it kind of distributes, but it hasn't cleaned it up yet. So I'll double click on the x, and it turns x times x squared into x cubed, and x times x, it'll turn into x squared, and I'm just going to move this over a little here. And I'm just going to show all the steps. And I kind of like that. I like those steps. But maybe you don't want to show the 3x times 2x squared. Or maybe you like that, but maybe you don't want to show 6x times x squared and 15 x times x. These steps maybe aren't so necessary. So I'm going to collapse these and just do that as 2 steps. So I've got my distribution, and then I simplified each term. You can choose what you want to show and what you want to hide. Here, for example, 6x squared minus 5x, it's already simplified. I can't add these terms, it'll shake me off. I can't do anything with the exponent or multiply. What I could do is factor it. So there's an x in each term. I'm going to grab one x and drag it over onto the other one to make it obvious that they have an x in common as a common factor, and it factors it out. It's pretty cool. Again, I'm not doing any typing here. There are some things you can do with a keyboard, but there's a lot you can do just by pointing and dragging. Here I'm going to click on the squared. A plus b squared becomes a squared plus 2ab plus b squared if I expand it out. And there's other kinds of expansions and factoring you can do using these formulas. There's, of course, the quadratic formula. There's you want to set up manual factors, you can do that, and then you'll have to enter what you think they are, or difference of squares, or quadratic binomial like the one I just did, difference of cubes or sum of cubes. It has all these different sort of formulas you could use. So I really like graspable math. It really puts the user in the driver's seat. You get to select what you want to do as opposed to it being completely autonomous. Certainly encourage you to try some of these things out. I spoke to the developer of Graspable Math, and he was telling me that they don't really consider it to be the same as computer algebra systems, and I agree, it's a little different. The term they use is dynamic algebra notation, DAN. When I think back to when I used Fathom, we call that dynamic statistical software, or when we use things like GeoGebra or Geometry Sketchpad, we call that dynamic geometry software. So this is called dynamic algebra notation. I love it. You can gesture, you can move your finger around. It's like a conductor conducting an orchestra. They're not playing an instrument, but they are telling the musicians when to play and when to come in and what to do. So the user's still in control. I set up this sort of spectrum here. At one end of the spectrum is graspable math, where it's user directed. At the opposite end of the spectrum is some software you may have heard of. It's called Photomath. You can get an app for your smartphone, take a picture of a problem, and it just gives you the solution. Figures out what you need to do, and it just does it. You can ask it to show you step-by-step steps showing what you could do, but you don't have to look at that, and you don't at any point tell it what to do. It just looks at the question and answers it. So that's autonomous Photomath. Graspable math is user-directed, and somewhere in between is computer algebra systems. They're not quite the same. If you ask it to do something like complete the square, it just completes the square. You don't have to tell it what to do at each of the steps, right? So it does an entire algorithm, whereas graspable math will do pieces of an algorithm if you gesture to do it. A little bit different. I'm going to try and very briefly take you through the curriculum document here. This is the grade 9 and 10 curriculum document. If I do a quick little search for computer algebra systems, you'll see that it shows up not only in the preamble, but in some of the actual expectations. For example, add and subtract polynomials with up to 2 variables, using a variety of tools, and you notice it specifically mentions algebra tiles, but also computer algebra systems, paper and pencil. There's different ways that it wants you to show students how to add and subtract polynomials. The same is true for the next expectation, multiply a polynomial by a monomial, using a variety of tools, and it names computer algebra systems. Expand and simplify polynomial expressions, again, using a variety of tools. Here's one, solve first degree equations, including equations with fractional coefficients, using a variety of tools. And even in 2005, when this curriculum document came out, computer algebra systems was named specifically. Many of us weren't ready in 2005, didn't have the technology, but I think, I feel like now in 2020, that technology is much more freely available. Students can download an app, they can use a browser and access it on their own. They don't need to come to school. They can access it at home just as easily. Here's another expectation. Rearrange formulas involving variables in the first degree with and without substitution. It's the without substitution part that I find interesting, but computer algebra systems and the dynamic algebra notation in graspable math, they could handle that. It doesn't name computer algebra systems specifically in this expectation, but here's another example of something that could perfectly well be done with or without computer algebra systems. So really the list of expectations for which this technology is applicable is quite long, and there are also many examples in the senior grade 11 and 12 document. Have a look, and I think you'll find lots of places where we could be using this technology. I want to leave you with some discussion questions. So if you're working with somebody else, with a colleague, maybe you could take a few minutes to discuss some of these. Here's a big one that comes up a lot, and it's one of the reasons why in my own department we were reluctant to start using computer algebra systems until fairly recently. If we allow students to use computer algebra systems, will we be preparing them for grade 11 or 12 college or university destination courses? I would say if you have some effect over what happens in those grade 11 or 12 courses, then maybe you are preparing them. And I would suggest that you don't necessarily want the computer algebra system to be a crutch, but a tool that they could use, as well as other ways of representing the algebra. So with paper and pencil, or with diagrams, or algebra tiles. There's lots of different ways we want students to access the algebra. Will we be preparing them for post-secondary studies? Maybe I'll leave that for you to discuss. If a question, this actually is a question that was originally posed by Dan Meyer, and others have asked similar things. The third one on this page says, if a question can be done using computer algebra systems or photomath, should we be asking different questions? If we're asking questions that are really about calculation, maybe we need to rethink that a little. Or here's a good one. The second question here, would you allow students to use spell check when writing? Would you allow students to use spell check when writing a spelling test? Would you still give students spelling tests if they had access to spell check? It's not exactly the same as spell check, but there are some similarities, and maybe that would inspire some thought-provoking discussion. I want to thank you for joining me for this session. If you'd like to spend more time on this, please reach out to me. I have been, for the last couple of years, a hybrid teacher coach. I do sessions specifically on computer algebra systems, which means you can come in and watch me teach, and we can do a half-day PD session on it with yourself or your colleagues. Thanks again. I hope you have a great start of the year and a good September.